Hi everyone, this is again from a past paper and it's further pure maths 3 and it's question number 5 of 2024 May June, the latest one. Okay, so they've given us a quadratic equation and for part A they're asking us to find the value of P and Q. So they're asking us to write the quadratic equation as a what do you call it, competing squares. That's a competing square format. So what you can do is you can write 4x squared plus 4x plus 17. Your first step should be you take 4 out, okay? So then you end up with x squared plus x plus 17 over 4. And when you do competing squares, keep 4 outside. So focus on what you have inside the brackets. So when you do competing squares, you look at the coefficient of the x term. So it's 1, right? So that term should always be divided by 2. Whatever the coefficient in front of x is, whether it's minus or plus, it should be divided by 2 and it should be in brackets with like this. So it should be x plus half in brackets squared. So let's say it was, instead of 1, let's say it was minus 3 or something. So then this becomes x minus 3 over 2 in brackets squared. Okay, so I hope you understood. So then your next step is minus whatever you have inside, the number you have inside the brackets, minus half. It's always minus. Okay, remember that. Minus half squared plus 17 over 4. So that gives you x plus half squared. So you just put that in your calculator, minus 1 over 4 plus 17 over 4, which gives you plus 4. Okay, this is in brackets. You had 4 outside, right? Now let's expand them. So we have 4 into x plus half squared plus 16. Okay, so this is our competing square format. But in the question, they've given 2x inside, right? So what we do is, we have to take this 4 inside. We should take it into the brackets. So when taking 4 inside the brackets, you can see the power is 2, right? So when taking inside, it's gonna be 4 to the power 1 over whatever you have the power outside the brackets. That's the rule, okay? Plus so that gives you 2x plus, so this is 2 into half, that's 2x plus 1 squared plus 16. So let's say they didn't ask us to write it in this form. So if we need to take this 2 out, when you take 2 out, it should be squared, all right? So 2 squared comes out, and you divide every term inside the brackets by 2, okay? So that's really good. So this is our format. And they ask the values of P and Q, right? So P equals 1, Q equals 16. That's your first part, and that was just 2 marks. And then they're given that 8x plus 5 over square root 4x squared plus 4x plus 17. Was it minus 17? No, it's plus. Yeah. Plus 17 equals to 1 over 4x squared plus 4x plus 17 plus 3x plus b. This is just 1 mark. I don't even know why they gave something like this, but yeah. 2x squared plus 4x plus 17 Okay, so you can see the bases are all the same, so you can write 8x plus 5 equals to 1 plus 8x plus b, right? So x terms you write together, so you can write 8x equals ax, and then you can write 5 equals 1 plus b. So a equals 8, b equals 4. Oh, I think this has a relationship to your next question, see, because they've given 8x, so we have to break that down into 2 like that, and then differentiate it. Okay. So now, part C. So part C, they've given to find the integration of 8x plus 5 over 4x squared plus 4x plus 17 dot dx. Yeah, so we have to break this down into these two and then find the integration. That's why they've given it like that. So this you can write as the integration of 1 over 4x squared plus 4x plus 17 dot dx plus the integration of 8x plus 4 over 4x squared plus 4x plus 17. Yeah. Okay, and now let's integrate it. So what we can do first is, no, I forgot to put in the square root. So that's 1 over square root. Instead of writing 4x squared plus 4x plus 17, what we can put in is the competing square formula, right? So we can write 2x plus 1 squared plus 16 dot dx. So let's integrate this first. Okay. So what we can do here is, let's take 16 out. This number, let's take that out. You see why I'm doing that, okay? So 1 over, so when you're taking 16 out, it's going to be 16, and this is a root, right? So 16 to the power half into 2x plus 1 squared over 16 plus 1 dx and integration. So 16 to the power half is 4, right? So I'll take 1 over 4 out, and this I can rewrite like this. 2x plus 1 over 4 in bracket squared, right? If you expand the brackets, you get 2x plus 1 squared over 16. Okay. Now, let's take the substitution. We'll take u equals 2x plus 1 over 4. So let's differentiate this, because we need to find du, right? Then du over dx equals 2x plus 4. 2x over 4 is half. X, so that's just half. Right? So du, let's cross multiply, 2 du equals dx. So now you can put 1 over. So instead of that, you can put u squared plus 1 dot 2 dot du. So 2 into 1 over 4, that's half, into 1 over u squared plus 1 in the square root dot d, right? So what is this now? So this is the integration. You have to remember this. You'll definitely have it in your formula sheet. If you want a separate video of proof of how I get it, you can just drop them in the comment sections. Or else with memory, you can just memorize this. So the integration, so it's like this. The differentiation of shin inverse x is 1 over root x squared plus 1. So in this case, it's u, okay? So you can see the integration of 1 over square root u squared plus 1 is going to be, so it's going to be half into shin inverse u. Yeah. And instead of u, you can sub in the substitution you took. So half shin inverse 2x plus 1 for 4. And remember, these are hyperbolic functions, okay? So that's your first part. So this is pretty easy, right? Not that complicated. So if you differentiate this, you should get the integration we had. Here we leave this aside for now. And then let's focus on our other integration. So we have 8x plus 4 over. So instead of writing the quadratic equation, you can write 2x plus 1 squared over 16, right? So we'll take 4 out from the numerator. So you have 2x plus 1. And from the denominator, the same way we did earlier. No, you don't have to do that for now. You just leave it like this. So 2x plus 1 squared plus 16. Dot dx. Okay. So this integration is actually easy. So what we can do is either write u equals 2x plus 1. We'll take that as the substitution. So we'll find d over dx. So that's 2. So half du equals dx. So let's put in the substitution. So I'm just going to put the half in front. So 2x plus 1 is u over u squared plus 16. Or inside the root dot du. Okay, so this is actually easy. So what you can do is you write u squared plus 16 to the power minus half. Okay, I just took it up. Dot du. So what you can do here is you actually don't need to you could take a substitution if you like. Okay, let's take a substitution again. So let's take t equals u squared plus 16. Okay, so now you differentiate. We find dt over du equals 2u. That's it, right? And we subject du. So dt. So 1 over 2u into dt equals du. So that is 2 into u squared plus 16. So instead of u squared plus 16, we'll just put t to the power minus half. And instead of du, we put in 1 over 2u dot dt, right? So you can see u cancels off. 2 cancels off. So you end up with the integration of t to the power minus half dot dt. So that is t minus half plus 1 minus half plus 1, giving you 2 t to the power half. So 2t to the power half. So that was 2 into t. So t was u squared plus 16. And instead of u squared, we put in 2x plus 1 instead of u. So it's 2x plus 1 squared plus 16 to the power half. That is your second integration. Okay, so now you can write both the integrations together because they were those were the additions, right? So you can write half shin inverse 2x plus 1 over 4 plus 2 into 2 plus 1 squared plus 16 to the power half. This is your final answer. Okay, plus c. But in this case, we don't have to put c because they were asking us the value. Okay, so they've given us two intervals, 1 over 3 to 1, and they've asked us to find it in that format. They've given k plus half ln k. So let's put our intervals now. 1 over 3 to 1. So let's put in 1 first. So we have half shin inverse. So 2 into 1 is 2. 2 plus 1 is 3. 3 over 4. Plus 2. 2 into 1 is 2. 2 plus 1 is 3. 9's 3 is, so that's 25 to the power 2. So 25 to the power half. So that's 10 minus, let's have say 1 over 3. Half shin inverse. So coming to 1 over 3 plus 1 divided by 4. That's 5 over 12. Plus 2 into 1 over 3 plus 1 squared plus 16 to the power half. You see 20 over 3. Oh, wait a minute. Then multiply them by 2. 9 plus 16. 3 plus 1 squared plus 16. Well, 2 into 1 over 3 plus 1 squared plus 16. Oh, this is actually 13 over 3. 13 over 3 into 2. My calculator is crazy for some reason. And just check that again. 1 squared plus 16. Yeah. So yeah, it's 13 over 3 into 2. So let's take our values first. So we have 10 minus 26 over 3, giving you 4, 3. Let's keep that separately. And we have half shin inverse 3 over 4 minus half shin inverse 5. Yeah. And you should know shin inverse x is ln x plus root x squared plus 1. This will also be there in your formula, see? But you can remember this, you know? Yeah. Now let's sub in our values. I'm just putting them in the calculator, right? So your first part is half ln shin inverse 3 over 4 is ln 2 minus half, and I'll put the other part in the calculator and see what I get. So that gives you ln 13 over 12. Let me check that again. Oh, I'm sorry. I get it as 3 over 2 now. Let me just recheck one more time. 5 squared plus 1 plus 1 is 13 over 12 plus 5 over 12. Yep, 3 over 2, sorry. And then, yep, this is what you get. So now you can write half. You can take half out. And then you have ln 2 minus ln 3 over 2, right? So Minus means it's the division of the numbers inside the brackets. That's the rule, logarithmic rule. So you get half ln 4/3, right? So this was your second part of the answer. And was your first. So your final answer is 4/3 plus half ln 4/3. So the answer format they've given in the question was k plus half ln k. So it was k plus half ln k. So you can see k equals 4/3. So this is your final answer. It was a pretty long question. If you guys have any doubts, just drop them in the comment section. And yeah, that's everything. Thank you. Have a great day.